Exercise 1. In order to help an isolated village, a stationary helicopter releases boxes of food supplies from a height HA equal 50 meter. HA, we have HA equal 50 meter. Each box is provided with a parachute. The set S box parachute has a mass M equal 50 kilogram. S released at A without initial velocity. That means VA equal to 0. So VA equal to 0 meter per second. Moves down along the vertical trajectory ABC and reach B of height HB. We have HB equal 45 meter with a speed VB equal 10 meter per second. See the figure. The horizontal ground is taken as gravitational potential energy reference. So this is the reference. Then on C, the GP equal to 0. Take G equal 10 meter per second square. Part 1. The parachute remaining closed while falling from A to B. All the forces of friction are thus neglected. Then friction equal to 0. Part A. The mechanical energy of the system as Earth is conserved along the path from A to B. Why? Since Part A 1A, since friction is neglected. So mechanical energy is conserved. Part B 1B, specify the transformation of energy that takes place while falling from A to B. The potential energy is transformed into kinetic energy. Since from A to B the height will be decreased, then the kinetic energy will be increased. So the potential energy is transformed into kinetic energy. Part 2. Upon reaching B, the parachute opens and the set S continues its falls at a constant speed of 10 meters per second until it reaches C. Vc equal 10 meters per second. Part A. Find the decrease in the mechanical energy of the system S Earth when it passes from B to C. The decrease of mechanical energy, it is absolute value delta ME. So it's equal absolute value ME at point C minus ME at point B. This is very important. While ME at point C equal kinetic energy at point C plus gravitational potential energy at point C. Kinetic energy equal half mvc square plus GP at point C, it's equal to 0 reference on the reference plus 0, so it's equal to half times 50 times Vc equal 10 square. We obtain 2500 joule, so it's equal to 2500 joule. Mechanical energy at B, it's equal kinetic energy at B plus GPE at B equal half mvb square plus mghb. So it's equal half times 50 times VB, it's equal 10 square plus m, it's 50 times 10 times hb 45. We obtain mechanical energy at B equal 25,000 joule minus 25,000 joules. We obtain the decrease is 22,500 joule. This is part A. Part B. How does this loss of energy appear? This loss appeared in the form of thermal energy or heat. Part 3. One of the parachutes did not open while falling from A to C. Determine in this case the speed with which this box reached C. Friction equal to 0, then mechanical energy at point A equal mechanical energy at point C. Mechanical energy at point A, in this case, it's equal to mechanical energy at point B, 25,000 equal mechanical energy at point C, it's equal to kinetic energy at C plus GPE at C. That gravitational potential energy equals 0 on the reference. So 25,000 equal half mv square, vc square, 25,000 equal half times 50 times vc square. We obtain vc equal 31.6 meter per second. 4. What can you conclude about the role of the parachute in the fall of the box? The parachute reduces the speed of the box upon impact with the ground. So, the parachute reduces the speed of the box. Exercise 2. A solid S of mass m equals 0.1 kilogram is launched with an initial speed VA equal 10 meter per second from point A up the line of greatest slope of an inclined plane S, stops at point B, then moves back downward. It stops at point B, so VB is equal to 0 meter per second. The height of point B is h equal 4 meters, so HB equal 4 meter above the horizontal plane passing through A. This plane being taken as a gravitational potential energy reference, so this is the reference. So GP at point A equal to 0 since it's on the reference. Take G equal 10 meter per second square. Part 1. S rises from A to B. Part A. The system S Earth gains gravitational potential energy Y. The gravitational potential energy of S increases with height, since height increase. The height increase. Part B. Calculate the values of mechanical energy A and mechanical energy at B of the mechanical energy of the system S Earth at A and B respectively. Mechanical energy at point A, it's equal to gravitational potential energy A plus kinetic energy at point A. Gravitational potential energy is 0 on the reference, plus kinetic energy at A equal half mva square. So it's equal half times 0.1 times 10 square. It's equal to 5 joule. This is mechanical energy at point A. Mechanical energy at point B. it's equal gravitational potential energy at point B plus kinetic energy at point B equal mghb plus 0 without initial speed. So it's equal to 0.1 times 10 times 4, it's equal to 4 joules. Part C, calculate the decrease in the mechanical energy. The decrease in mechanical energy is equal to absolute value of delta ME equal absolute ME at point A minus ME at point B equal 5 minus 4, it's equal to 1 joule. So this is the decrease in the mechanical energy. Part D, in what form of energy does this decrease appear? Thermal energy. Part 2, S descends from B and passes through A, from B to A, like this. Knowing that the decrease in the mechanical energy is same during the upward motion and the downward motion. So delta ME, it's equal to 1 joule in absolute values. Calculate upon returning to point A the mechanical energy of the system as Earth. Then we must to calculate mechanical energy at point A. We have ME at A minus ME at B equal 1 joule. So ME at A it's unknown minus ME at B it's 4 equal 1. So by applying the concept of absolute value, ME minus 4 equal 1 or ME minus 4 equal minus 1. So we obtain ME at A equal 5 joule or ME at A equal 3 joule. Why the motion from B to A and the mechanical energy it decreases? So ME at A equal 5 joule it rejected, since 5 joule is greater than 4 joule at point B. So the mechanical energy in this case at A equals 3 joule. Part B, the speed of S. Calculate the speed of S. ME A equal kinetic energy at point A plus GPE at point A. GPE it's equal to 0. So 3 equal half mVA square. We obtain VA square equals 60. Then V equal 7.74 meter per second. Exercise 3. Consider the track ABCD situated in a vertical plane and represented in the adjacent figure. A solid point mass S of mass m equal 2 kg is released without initial speed from point A, so VA it's equal to 0 meter per second, at a height HA equal 5 meter above the horizontal level BCD of the track. Take the horizontal plane through BCD as gravitational potential energy level. So this is the reference. Then gravitational potential energy at B and C and D equal to 0. Neglect all friction on the inclined part AB of the track. So friction equal to 0 and G equal 10 meter per second square. Part 1A, calculate the value of the gravitational potential energy of the system as Earth at point A. GPE at point A equal mgha equal 2 times 10 times 5, it's equal to 100 joule. Part 1b, deduce the value of the mechanical energy of the system as Earth at point A, mechanical energy at point A equal GPE at point A plus kinetic energy at point A. GPE is equal to 100 plus kinetic energy is equal to 0 since velocity equal to 0. So ME equal 100 joule. Part 2, the mechanical energy of the system between A and B is conserved. Why? Since friction is neglected. Since friction is neglected. Part 3, using the law of conservation of the mechanical energy between A and B, determine the value of the kinetic energy of S at B. ME at A at B, it's equal to ME at A. Then kinetic energy at B plus GPE at B equal 100. And GPE at B equals 0, reference. So kinetic energy at B it's equal to 100 joule. This 3A. B, verify that the speed of S at B is 10 meters per second. Have mvb square it's equal to 100. So half times 2 times vb square equal 100. Then vb square equal 100. And vb equal radical 100 equal 10 meters per second. Part 4. After leaving point B, S reached point C with the speed of 6 meters per second. So Vc equals 6 meters per second. For A, calculate the value of the mechanical energy at point C. ME at C equal GPE at C plus kinetic energy at C. GPE at C is 0 on the reference. So it's equal 0 plus half mvc squared to obtain 36 joule. Part B, show the existence of a frictional force on the part BC of the tract. We have mechanical energy at C different than mechanical energy at B. Then ME is not conserved. Then friction exists.